Okay, I want to start with our quantitative data, our mean, median, and mode concept, and then we're also going to do the outlier rules. Now, we had previously talked yesterday when we took care of describing the distribution with our SOCs about that relationship between the mean and the median and the mode. And we had talked about how outliers affect things. Remember that we said if you have skew, then you need to choose median and IQR, symmetry, standard deviation, and mean. Okay, so that gave an indication of when we should use those items. But I wanted to talk to you about what makes which direction the mean goes to. And so how does it change? And does it get smaller or does it get larger? And so one year I had a student show me this trick, and I've used it ever since, and so it's really helped. So if you write the words mean, median, and mode in order, in its alphabetical order, then if you draw an inequality in the shape of the distribution, so for example, if you have one that is skewed left, okay, remember skewed left shows a stretch to the left, okay, then we're going to draw an inequality that points to the left, okay. So if it's skewed left, then we have an inequality that points to the left, and then you can see from this that the mean is less than. The mean is less than the median, and the median is less than the mode. Okay, so that way you know the mean is a smaller value. All right, but then we also have the opposite. If we have a distribution that is skewed to the right, so if we come over here and look to the side and we have one that is skewed to the right or stretched out here to the right, okay, then we've got inequalities. We want to point to the stretch, so we're going to point this way to the right. So we know then if we have a distribution that's skewed right, the mean will be greater than the median, and the median will be a bigger number than the mode. Okay, and so that is as simple as the rules get. Now the one last one is that if it is a symmetrical distribution, then the mean and the median are pretty much equal, and they're pretty much equal to the mode. Okay, so that is the ends to how you can tell the relationship between the mean, median, and the mode. Now on this page that we had seen yesterday that had all the shapes, down here at the bottom we also see that as well. Okay, we see that if it's symmetrical, then they're pretty much equal. If it is skewed left, then we've got the mean is less than the median. Okay, and if it is skewed right, then we've got that the mean is greater than the median. And then we'll write here on this middle one, the mean is less than the median. Okay? All right, so let's keep that in mind, and let's go ahead and take a look at this first problem here on this page. So what we see here is in 1997 there were 88 quarterbacks on the National Football League roster, and they earned an average salary of either $58,750 or $89,354. So they're not telling you if these two numbers are the mean, which one is the mean and which one is the median. And we want to know if you can figure out which one is the mean and which one is the median. So this is based off of the skew of this distribution. So my question is, do you think when you talk about salaries of football players, would you have upper outliers and make it skewed right? Or would you have lower left outliers and then everybody's pretty much shaped up here at the top? Which ones do you think you would have more likely be the salaries of the players? Okay, I think most people can see that you're going to have a few of these upper outliers. You know, some people get paid a whole bunch when the others are kind of clustered down there together. So since this is skewed right, we know that the mean is greater than the median. And so based on that fact, that the mean must be greater than the median, you can tell that the 89,354 must represent the mean, and therefore the 58,750 must represent the median. Okay, so um, that's the kind of thought process that you go to. And of course, again, the reason is because that the salaries are skewed right. So you will follow that thought process here on the rest of these. So say number 2, if you turn your head, you know, you have the stem and leaf plot, but if you just turn your head sideways, then you can see the shape of this distribution. And you can see it's skewed. And then I want you to pick the answer there. So you'll go back and do that in a second. And okay, so on and so forth. So I want you to, in a moment, you will finish this page. But next, I want us to talk about outlier rules. We had mentioned this also yesterday when we described our distribution with our socks, so that we could actually calculate if we had outliers. So let's recall the 2 sets of rules. Okay? So if you're going to use the Iqr rule, then the upper fence will be Q3 plus 1.5 IQRs. Okay, and then the lower fence is Q1 minus 1.5 IQRs. Okay, so that's that rule for those. Now, if we end up having a distribution that's somewhat symmetric, and we're going to use the standard deviation, because symmetry, use standard deviation and mean, then our rules for the outliers there. The upper fence will be the mean plus 2 standard deviations. Now this is not the number 20, this is a sigma, so 2 standard deviations. And then the lower fence is the mean minus 2 standard deviations. Again, this is not 20, this is 2 sigma. All right, so there is the summary of our rules that we will choose. And so let's take a look at our information here. So it says, for each of the following sets of data, determine the outlier fences using the IQR rule and the standard deviation rule, and then determine the number of outliers. So we have a computer printout here. Okay, and this is something that happens frequently. If you go into a business and you use these, you're going to see a computer printout. And so I want to take you through that computer printout and talk about the things you will need and the things you won't need, or what those things are. So you can see we've got information on females, so they're going to be the top line, and then we've got information on males, they're going to be the bottom line. All right? This N, what do you think that N represents? Okay, that N is the number of items in the data set. Okay? Here you can see the mean of both the female and the males. Here you can see the median. Now, this trimmed mean is not ever going to be used with us this year. Okay? If you use the standard deviation rule, then here's where those standard deviations are located. And of course, again, the top line is females, the bottom line is males. And this standard error of the mean, that's not something that we will talk about ever either. Okay, so you don't even need to mess with that. Okay, so we're going to use the minimum value of the data set and the maximum value of the data set shortly. And then, of course, you have your Q1 and your Q3. So if we do the IQR rule, then as you can see, IQR is not listed here. However, you have the tools to figure out the IQR. Okay, so let's take a moment and do that real quick. So let's figure out that IQR rule, or figure out that IQR. Remember your Q3 minus Q1. Okay, so do that computing on both of those. Okay, I did the subtraction on those. The female IQR was 5.75 and the male IQR was 6.75. Okay, I'm going to do one of these items with you, and then you will do the other three sections. So the first section that we're going to do, the one that we are going to do together, is this female rate. So we want to look at the female numbers, and we want to do the IQR rule. All right, so I'm going to write our formulas in here that we are going to need for our upper fence and then our lower fence. Okay, I'm going to let you take a moment, fill in those numbers, and get those fences. So do that. All right, so I have gone ahead and calculated those amounts. So we have an upper fence at 26.375. We have the lower fence at 3.375. And so I want to talk to you about how we then figure out if we have outliers. So to do that, I'm going to kind of give you an idea with a picture. Okay, so we have our box going on here. So I'm not going to actually put it on a scale and everything. But you can tell, you come out here and then you have an outlier fence at 26.375 for the upper. Well, what I am going to look at is see if the maximum value for the females is above the upper fence. That's what the first thing you check, is the maximum above the upper fence. And the maximum being 21 must be in here on the inside of the fence, not above the fence. So therefore, I can say that there are no upper outliers because the maximum is inside the fence. Okay, now we do that same thing for the lower fence. So we know we'll have our information out here, and then we've got ourselves a fence down here at 3.375. So what value do you think we're going to look at to determine if there's a lower outlier? We're going to look at that minimum value. That minimum value is 2. So what do you have to say about that minimum value of 2? It is lower than the lower fence. So if your minimum is lower than the lower fence, you have a lower outlier. And the way we write that, now there could be more. We don't know. Since we don't know all the data, there could be more in here. So we say there is at least one lower outlier. So that's how we write that. At least one lower outlier. Okay, so no upper outliers because the maximum is not outside, and at least one lower outlier because the minimum is below the lower fence. So that is how you figure all of those out for the rest of these. So you will continue the other 3 sections of this. You will now do the standard deviation rule. So you'll fill in your numbers and get different fences and then determine if you have outliers. And then you will use the male information, which is from the male line of that computer printout. Okay, so what I want you to do then, in summary, is to finish this page here on the information on the mean, median, and mode, and their skew and such, and finish your outlier problems here and determine the number and type of outliers.